I'm Bart Fetler, Senior Data Scientist at Forest Bridge AI Consulting. The topic I'd like to address today is large language models are biased and inaccurate. Can they be improved? LLMs are not always accurate. They have become extremely popular. ChatGPT, Bard, Llama, etc. But they are known to hallucinate and do not always produce accurate output. Why is that? Let's explore some ideas. What do we mean when we say LLMs hallucinate? They produce large amounts of text, sentences and paragraphs. From an NLP perspective, the sentence structure and parts of speech are mostly correct. However, the named entities produced may be incorrect, and the relations between the entities may also be incorrect. For example, the New York Times asked ChatGPT for the first mention of AI in New York Times articles, and it replied with an article from July 10, 1956, which did not exist, although there was a conference around that time. They asked the same question of Bard, and it replied with an article from November 1955, which does exist, but it gave a made-up name for the reporter, which is similar to a known computer scientist. When Google announced Bard, they had the sentence, "The James Webb Space Telescope took the very first pictures of a planet outside of our own solar system." Now, the entities here are correct. There is a James Webb Space Telescope, and there are pictures of exoplanets. However, the very first pictures of exoplanets were taken by a different telescope in 2014. So it's the relations between the entities here that's incorrect. And there's also an attorney who used ChatGPT to generate a case for him, and it cited many other cases which simply did not exist. So let's think about data and models. Transformers typically use medium to large data sets. LLM models use huge data sets, and all ML models need training data. No model is 100% accurate all the time, especially when you give it real-world data. And most training data is biased. How do we know biases? It depends on the data categories, entities needed, and the number of questions to answer. And there are standard methods for reducing data bias. You would measure or estimate the data bias in imbalanced data categories, and then stratify the data by those known categories into train, validation, and test data such that they're well represented in each of those buckets. And you might want to oversample or undersample imbalanced data or find relevant data from other sources. So how would this apply to LLMs? Let's start with a traditional NLP example. In case reports from PubMed, which is an online database of medical articles, I submitted a query on amlodipine, which is a drug used to treat high blood pressure. So what's the data distribution of the results of that query? It was about equally split for patient sex between male and female, with some bias towards male. However, it was heavily biased towards adults and the elderly, and represented in more than 90% of the cases, and very little for children. But especially, there were no female child or adolescent cases in this particular data set, which would make it hard to model. For the medical terms present, it follows a long-tail distribution typical of most vocabularies, with some very common terms and very rare terms. And a particular term of interest here is adverse effects, which are present in 40% of the cases, and a particular adverse effect of fatal outcome is present in 4% of the cases. So how would we correctly stratify the data? Well, we can estimate the categories by multiplying the probabilities of all the known data categories, say for patient sex, age, medical terms, etc. And these estimates would give a rough distribution of the probabilities, although the exact numbers would differ due to data correlations. And of course, the data will be biased towards the most common values. For example, for adult females with adverse effects, it's present in about 9% of the cases. It's not too difficult to stratify. For adult males with a fatal outcome, it's about 1.3%, it's much less. For female children with adverse effects, the estimate is that it's about 0.8% of the data, but it's actually 0 because there is no such data in the data set. Whereas for male children with hypertension, which is a common adverse effect, it looks about 0.9% of the data, but it's actually 1.6% because it's overrepresented in the data. So the main point I'm trying to make here is that it's difficult to stratify and model rare terms, which is not uncommon in real-world data. What about large language models? The model we know the most about is GPT-3. The authors of that model recognized data bias in their training set. They said, internet-trained models have internet-scale biases, and models tend to reflect stereotypes present in their training data, and they are able to show bias in gender, race, and religion. If we look at the data buckets that were used for the training data, there are 5 buckets, and here are sort of the top topics that are present in each of them. But this is really just an overview. There's really a long tail distribution with thousands of topics and subtopics, which may be relevant for some particular question that a user might submit to GPT-3. So from an NAR perspective, how many biased or imbalanced categories are there? There's a huge number of entities. There's an enormous number of questions that people can enter, and therefore it's an exponentially complex bias problem, probability 1 times probability 2, etc., for each category within a question. So how would you stratify the data for multiple questions which may have different categories? Data splitting and stratification may become a problem as large as the corpus itself, and very difficult to deal with accurately. So one may say that LLM models are inherently biased by their training data. For GPT-3, each data source is inherently biased. The data preprocessing and query filtering in the algorithms may help reduce the data bias. But even if all entity out distributions are known for all given questions submitted by users, it is likely impossible to stratify the data. Now, for the newer models, GPT-4, BARD, Llama, the data for those models is not publicly known. But we can conjecture that due to the exponential complexity of entity categories and queries submitted, it seems it would be impossible to stratify the data to remove bias. So what can we do? How would we make LLMs useful? I would suggest to focus on a limited number of questions for a particular application, and think of it as entity recognition for a particular domain. So think about the data. It's often said that the data is the model, and this is even more true for LLMs. So you want to focus on reliable data sources, task-specific data, and not false or irrelevant data. And of course, that depends on the domain, whether it's legal, medical, advertising, etc. And this is really a very old computing problem called garbage in, garbage out. You'd prefer not to have garbage in your training data. So you might want to focus on building smaller, less costly, domain-specific large language models. For example, for legal topics, you'd want to use legal journals, the online database Westlaw, United States patents. You probably would want to ignore most novels because most of them are not about legal cases, and the sentence structure probably is quite different between legal documents and novels. For medical topics, you'd want to use medical journals, reliable articles. You wouldn't want to use political articles because politicians write quite differently than doctors. For advertising, you want to use ad copy from various companies online. You would not want to use technical journals in science because, again, the language would be quite different. For relationship advice, you'd probably use Dear Abby columns, Match.com, romance novels. You really wouldn't want to use GitHub code because that would just be irrelevant. Now, there are some open questions. Does inherent data bias imply creation of fake entities in LLMs, such as Alfred Einstein instead of Albert Einstein? Not necessarily. It may be fundamental to the model algorithms themselves. However, biased data will bias the entities that are produced. And what are entities? Not just tokens or words, but actual phrases from human experience in real life. Proper names, medical terms, literature references, those should all be real entities. Now, the tokens and word vectors used in LLMs and transformers usually do not contain whole entities. So can we build LLMs to produce only real entities? And how would that be represented in the data? So that's my talk. Please contact me if you have any questions. My email is bfetler@gmail.com. You can also find me on LinkedIn. Thank you.